Well, welcome to the talk. My name is Fabian. I'm a software developer and co-founder and CEO at KYVE. And today we're going to talk about how we validate data in Web3 and what this means and how you can build your fully decentralized data lake with that. Maybe some quick backstory about myself first. As I said, I'm a software developer from Germany. Started out working like some local Web2 startups, and then from there got into Web3 in summer 2020-ish, I would say, probably by a hackathon, and then just like probably everyone else, you get just torn into it, and then started working full-time on it in, I would say also in kind of end 2020, created my first project there together with the same co-founder, KYVE, John. Said to the ones in the audience, he's sitting behind there as well, so like half of the other credit goes to him for all that stuff we're building. And then in February, we kicked off our, February 2021 actually, we kicked off our journey towards KYVE. So as I said, this talk's going to be like pretty easy going. We have to unfortunately skip the demo part, but we're just going to talk a bit about like blockchain data in general, a bit about what KYVE is doing, and then like some milestone and roadmap we're going to hit with KYVE, and then at the end we have kind of an easygoing open Q&A session if there are any questions coming up. So basically one of the fundamental problems working in Web3 right now is data management in general. And I think we see this very well, especially at the Ethereum side and the EVM side, where it's became kind of like a piece of art for everyone and every developer here to like write a Solidity contract which is not explosive in gas costs, right? And this is mostly due to the call to storage, which is so expensive on Solidity. So basically, I mean, we see it happening, right? It's like there's no sane reason to pay $300 in gas for a Uniswap trade besides you making 10K profit, then it's fair, right? But there's no real like connection between actually the data management you do versus the price you pay for that. And so with that, of course, also comes the problem with indexing and retrieving these large amounts of data, because you have those very like defined data structures. The data is very condensed in blockchains in general, right? It's usually encoded. If you do it right, it's stored on some contract. You have to get the state of that contract, and so on and so on. And so indexing this data makes it more and more tricky, and I think we see it now coming up with the newer chains that this kind of like data management gets more easy, but especially on EVM or Bitcoin is probably like even the best example. It's like basically impossible index and retrieve the data from one place if you don't run your own node, or if you don't have your own node kind of hosted by someone, of course, creating some insane costs for you kind of managing that, right? And then the same problem with that also comes in with the backups and the snapshots you have to do of a chain. Basically because what do you do, right? They're usually centralized and reliable if you want to store your data. Let's say you're a node operator and you want to make sure your node never fails. So what you do is you create a backup of your node and you usually store it on Amazon S3, for example, right? But then every node operator kind of stores the same redundant data, and every node operator has the risk that actually the data they store might be corrupted, might be incorrect, maybe their node computed an incorrect state. And then, first of all, it starts off as only a problem for them, because they load in the backup, it's corrupted, then the chain doesn't start, like their node doesn't start, they don't make money, it kind of is that problem. But then if you now think about it, it would be like the foundation, for example, providing the snapshots for anyone to be able to recover from that. Then we have a very, very centralized point suddenly in this big decentralized system where in case something happens or in case something goes wrong, do you trust this entity storing the data? Because you can modify the state. I mean, we see this happening on chains which have to do some regenesis, some restarts. The actual data they do is that they modify the state, so the nodes load it in, they find consensus, and you're good to go on that. So that's kind of like the big problem coming in, and also something we try to solve over at KYVE. And there's also no way to cache state transition. That's kind of what I already mentioned with basically the state of the smart contracts or of the blockchains. It's pretty tricky to index it, make it available, and then also find it, basically, make it easy to access for developers through like APIs, which you know from the Web2 world, right? So they can use it kind of in their big like analytics stacks or in their systems. And the cost of distribution is very expensive, right? If every node in a network has to manage their own data, they all have to pay for the same cost, but they're all effectively storing the exact same data. So there has to be kind of like some way to be able to, centralize the data at one point, but still having it secure and still have it decentralized. But it should be one centralized point where the data is stored. So basically, this is the reason why we have created KYVE. And actually, it started out as a bounty set up by the Fabianriewe Foundation. And then John and I just started working on it. And the bounty was, is it possible to bridge over data from Polkadot on Arweave. And we actually wrote a script which does this, and then we were able from that to generalize the script to work for kind of any API. So we not only work with Web3 data, we also work with Web2 data, which you would like, for example, to store in a decentralized manner. So one very nice use case for that is, for example, the European Central Bank has an API for the conversion rates from euro to USD, which is used in every accounting software. That's like the central point of truth, right? But actually the access to that API is not available to everyone. It's like tricky, you need an API key and so on and so on. And actually what you can do with KYVE is you can store this data from them and turn it into a public good by making it accessible through our data lake, so that then anyone can publicly use the data, because it's the exact same information everyone in here uses for the same piece of data. So basically the way KYVE works is, you can see it here, we have any blockchain, any data source, we route it through KYVE, we store it on permanent storage like Arweave, and then you're able to retrieve it from there. And the system, we enable this to be fully decentralized, is the concept of a storage pool. So in a storage pool, you have a set of nodes, where one node, for example, pulls the data from an endpoint, stores it onto Arweave, and then takes the Arweave ID and proposes to the network, saying, hey, I've uploaded this piece of data, could the others please verify that it is correct? And then what's happening is the other nodes then fetch the data back from Arweave, they run a validation check against it. Usually it's like, oh, does A equal B, right? And if it's correct, then they vote in favor of this piece of data, and it's all secured by their personal stake, right? So what would happen if a piece of data is invalid and more nodes would vote invalid against this, the uploading node who uploaded the data will receive a slash for that. So it's punished, so never incentivized to upload invalid data. And then, if the data is valid, the blockchain, so we are a Cosmos SDK-based blockchain, emits an event saying, hey, actually this piece of data is correct. And then indexers, developers, whoever, could then use the data in their application and fetch it from there and make it accessible to anyone. So kind of once the data is in the data lake, there are tons of ways to utilize that. And actually, if we would like do it on an example-based thing with Polkadot, for example, it would be the uploader requesting Polkadot, like, hey, Polkadot node, could you please give me block number 5? And then Polkadot would return block number 5 to the uploader. He would do this, of course, for multiple blocks at the same time, compress them, store them, propose that he uploaded block number 5. The validators would do the same. They would fetch the same Polkadot API asking, hey, is block number 5 what the uploader uploaded actually correct? Well, yes or no, you vote in favor or against it. It's like a very easy system, but it's fully decentralized. So that's the way we kind of do that. Unfortunately, as I said, we have to skip the demo part on that. So I can talk a bit more through like the roadmap of KYVE and how everything got started. So as I said, we started out with our first integration as a bounty. So we started with, I think, Polkadot, Cosmos, Avalanche, and a lot of other EVM-based chains to store their data. Did a pre-seed round, did our testnet release. We have quite an interesting tech backstory. So we started out being completely Arweave-based, meaning that we were storing the data on Arweave, the same with our token logic and everything was running on smart contracts on Arweave. And from there, we noticed actually that the Arweave smart contracts were not production ready to the extent where we would need them in our system. And so we transitioned over to being having our logic sitting in an EVM chain and storing the data on Arweave. And so we actually deployed those contracts on Moonbeam and kind of run it from there. And then we noticed actually there is this one like drawback with EVM when you're developing on EVM, which is that it doesn't work well for high throughput applications, exactly due to those like storage costs and gas costs you have, because basically you always have to share the block space with other applications, right? Meaning others always try to outbid you, especially if you work with dApps, for example, Uniswap, right? Where you have fewer transactions, but they all have a high value, right? Because I think everyone in the audience would agree, if you do a 10K profit trade on Uniswap, you're fine with paying $100 in gas fee on it, right? But if you're just voting on a piece of data, like here in KYVE, maybe 50 times because we have 50 nodes validating the data, not every node is going to pay $100 to verify that, because actually maybe the data is just not worth $100 at all, right? If the data is worth 10,000, well, maybe they do it, but not for 100. So we were looking into other solutions for that. And then earlier this year, we then transitioned over to being EVM-based, to being our own Cosmos-based chain. And so we're still storing all the data on permanent storage like Arweave, but our chain logic is now a Cosmos SDK-based chain. This allowed us, of course, also some more flexibility in coding. And so we launched the protocol update with governance. We as a team always kind of like try to develop KYVE as being completely decentralized, so there's no control from us right now about the protocol. Every setting, everything is completely governance owned and completely governance structured as well. We're rolling out the incentivized testnet very soon in the next weeks, just for us to kind of like drive the community and get some more stable systems up and running. And of course, after that, it's really kind of like road to mainnet from us, trying to figure out where we sit and hope that the deployment this year also goes well. We have integrated with, I would say, probably almost every major L1 and L2 out there. The usual use case we have when working with them is archiving their data, basically just because we do some huge offloading of their work. And I think my most favorite example about this is Solana. Solana had such a massive growth that they had to implement a feature where actually the nodes start deleting the historical data. So what happens is there's actually only, as far as I know, one public endpoint available from the Solana Foundation itself, where you can get all the data as a developer, right? From all the others like Serum and so on, you can only get data which is, for example, a few months old, maybe a year old, right? There's no way to get the very old historical data. And actually this is kind of a centralized problem you face then, right? Because what do you do if the foundation is providing the endpoint? Do you trust them, right? Because there's no other way to verify. Do you trust that the data they are storing is correct? And then, I mean, you could spin up your own node, but especially on Solana, it's crazy expensive and crazy hard to manage running your own node. It's of course like a more developer burden, I would say, in the team. It's like, hey, you started from, I just want to access this old transaction on Solana, to like, oh shit, I need to run my own complete like full node stack to be able to retrieve that last piece of data. And it of course also leads to centralization, right? Because the only reason why you start pruning your data is because you want to be more cost efficient, right? You want your node to make more profit because the less infrastructure you run, the more profit you're gonna make. So it's kind of like a disincentive actually, keeping all the old data. And so of course it's obviously now only the Solana Foundation providing that because someone has to do it, right? If they start also deleting that, then they say, well, actually the data is lost and it's only a year and a half old. Like that's not good, right, on that side. And we see this with like the ETH 2.0 switch as well, right, with the merge and the purge happening. There's also no incentive for any clients keeping the old Ethereum data. Like someone could just go and just delete it, because why would you do it? You do less, you don't get any benefit for a user. They're not incentivized to provide the data you store. And that's kind of really where we try to come in as KYVE and like offload this burden from the foundations from that, because as I said in the beginning, let's take the ETH example, because that's like a really powerful use case, I would say. It's like all the old ETH transactions are the same. It doesn't matter which node you run, how many nodes you run, you will and you should always get the exact same data. So why not just store it in one place, but decentralized, and then offering it to anyone? Because then what will start is like, because the data is so condensed, right? We'll have indexing protocols like the Graph, like others, starting building their indexing businesses on top of this data lake. And this, of course, affects our tokenomics in a positive way, right? Because then people are starting to be independent on your data, so you start getting some recurrent revenues for the data storage. And actually, that's also one thing we do with KYVE is once data is stored, you pay once, right? Meaning that you create a pool, the Bitcoin pool, for example, but there's only enough funding in that pool to store the first 100 blocks, meaning that no one is basically open for future funding the pool, meaning there's also no demand in the data, right? If there would be demand in the data, then at some day someone pays for that for storing this. So basically the first 100 block gets stored on Arweave, and then funding runs out, so no one pays for that anymore. But the first 100 blocks will always be there. Anyone can always access this. And especially for Bitcoin, it's like a really, really great example as well, because we were experiencing that on our own. We released Slack last week, and there's something with Bitcoin happening as well. I'm not sure how much I can spoil here, but basically we're working with some Bitcoin stuff over there, and we actually had to go to Coinbase Cloud, right, and spin up a Bitcoin node there. So we have a way for us to reliably fetch Bitcoin data, because actually there is no other public way right now as a developer to get access to Bitcoin if you don't want to use any public nodes. So what we are doing now is we're now basically starting to archive Bitcoin, and then basically turning this private data, or like this private accessible data, into a public good. Because it's the same data for anyone. Anyone can start using that. Anyone needs it anyways, right? That's kind of how we come in with KYVE and with the role we play in the ecosystem. And as you see, I would say most of you are familiar with most of the projects on here. We also have quite a nice use case where we work with kind of the newer projects coming up, which have identified those scaling problems on their end and are immediately kind of like starting to integrate with us, so we immediately have the data. Unfortunately for FMOS, I don't know how much you guys are up to date with what happened on them, but they launched mainnet and their chain stopped. And basically what we were able to do is we were able to archive the data. So in theory, you would now be able to kind of recover from that place as well, instead of like having to look for some centralized node backup you could spin up from. Because especially if your state is corrupted, you really don't know which node did the correct state computation if you don't basically compute it by hand again, right? It's kind of like another nice thing we have on that. Next, I would say we just jump into like an open Q&A session. I don't think we have a mic down here. Just feel free if you have any questions, just ask them. I'll repeat them on stage so everyone kind of understood that, and then we can go from there. But yeah, feel free. Yeah.
Can I use your data if I don't have like any technical experience? So say like a researcher or something like that, I want to like create understanding without actually having to go through the data like technically?
Absolutely. So the question was if you can use the data without having a too technical background, if you're able to access this. So actually, for KYVE itself, I would most likely argue no, because what we do to cut costs on our side, we of course compressing the data and we're also bundling it up, right? Meaning we are packing the data more strongly than you usually can, so it's not human readable anymore and it's compressed as well. But that's where we roll out either our own indexing service or others like the Graph, for example, right? They utilize the data in their indexing service, so you as a, I would say, less technical developer or like as a less technical research person, you could use that, right? But that's kind of the perfect use case about how people use KYVE. We're very B2B driven, right? Meaning that we usually work on like data archiving is one aspect and then the data retrieval is the other side. And then our end users like you, for example, they would sit here, right? While the projects sit here, and it's like this loop kind of going in and out. And I also always like to say we're a bit like, I don't know, like the Intel or something of like Web3, because like my mom would never use KYVE directly, right? She would always use like maybe like a Uniswap, maybe some very like consumer-friendly UI, which then uses their technology and then uses basically KYVE in the backend for the data management part of things. Exactly. If there are any other questions. Doesn't really. All right. Well, I will be just down here in case there are any questions, anything coming up. Anyways, thank you guys for being here. Thanks for listening to that. I really appreciate it. And thanks for having me. Bye.